You click play on a YouTube video, and boom, it just works. But have you ever stopped to think about the absolute beast of a system that makes that simple click possible? Well, today, we're pulling back the curtain on the hidden architecture that delivers billions of videos to your screen every single day.
So, that brings us to the big question. How on earth do you even begin to build a system that can handle 5 billion, with a B, video views a day, from every corner of the globe, without ever breaking a sweat? Let's really dig into the scale of this challenge.
First up, let's talk about the users. We're talking 2 billion people logging in every single month. That's more than a quarter of the entire planet, and every single one of them expects a perfect, instant experience.
And all those people? Well, they generate a staggering amount of traffic. Get this, YouTube is responsible for 37% of all mobile internet traffic. Just think about that. Of all the data flying to phones around the world, more than a third of it is just for YouTube videos. That is a massive digital footprint. And it's not just about watching, right? On top of all that, the system has to handle a constant flood of new content from 50 million different creators, all uploading videos around the clock. The machine, it truly never stops.
So when you put all those numbers together, you see the core engineering problem. Let's call it the billion user challenge. How do you design something that's super fast, always reliable, and somehow affordable at a global scale? Let's see how they pulled it off.
To really get this, we're going to follow a single video file on its journey. We'll start right from the moment a creator clicks that upload button. This is where all the magic really begins.
Okay, so the very first challenge is speed. A huge, high-res video file takes time to move around, so YouTube's system does something really smart. It splits the task in two. The massive video file goes down one path, directly to a giant storage system. At the exact same time, all the little text details, the title, the description, they go down a completely separate, faster path to a database. Doing these things in parallel is the first big trick to saving precious time.
But hold on, how does the system know you're allowed to upload? It's not a free-for-all, right? This is where a really clever security step comes in. Your computer basically asks the main server, hey, can I upload something? The server then gives you back a special, one-time use key called a pre-signed URL. It's like being handed a temporary keycard that only works for one specific door. It makes sure your video goes to the exact right place, securely, without bogging down the main servers.
Okay, so our video is securely uploaded. It's in the system, but the raw file from a creator's camera, it is not ready for prime time. Not even close. Before anyone can watch it, it needs to go through this crucial, behind-the-scenes transformation. You could call it a total makeover.
And this makeover has a name. It's called transcoding. Honestly, the best way to think about it is as a universal translator for video files. It takes that one original file and creates a bunch of different versions, so that no matter what phone, TV, or computer you're on, or how fast your internet is, you get a version that's perfect for you.
So, why is this so critical? Well, first, there's compatibility. Transcoding makes sure the video just plays, no matter what device you have. Second, adaptive quality. This is huge. It creates all those versions, 1080p, 720p, and so on, so if your connection slows down, the video can automatically switch to a lower quality and you don't get that dreaded buffering wheel of death. And finally, it uses modern compression to save a ton of storage space. Now, transcoding is a really complex process with a lot of moving parts. To manage it all without anything getting lost, YouTube uses what you can basically think of as a smart recipe, or maybe a detailed project plan for every single video. Now, the technical term for this smart recipe is a directed acyclic graph, or a DAG for short. But really, it's just a workflow that breaks the huge job of transcoding down into smaller, individual tasks. And the key here is that the DAG lets a lot of these tasks run at the same time, in parallel, which makes the whole thing incredibly fast and efficient. So what's on this to-do list? Well, the DAG defines every single step. First, it'll inspect the original video for any errors. Then, at the same time, it can start creating all the different video versions, generating those thumbnails you see, and even adding a watermark if the creator wanted one. This flexible recipe is what lets the system handle millions of videos so efficiently. All right, our video is uploaded, it's been transcoded, it's gotten its makeover, it is ready for an audience. But how does it get from YouTube's server all the way to your screen instantly the moment you click play? The answer is something called a Content Delivery Network, or CDN. This is a massive global network of servers. So instead of streaming a video all the way from a data center in, say, California, the CDN puts copies of popular videos on local servers much closer to you. It's kind of like having a local library branch in your city, so you don't have to travel across the country to get a book. That physical closeness is what makes playback so fast and smooth.
So that CDN is the key to speed. But running a global network of servers like that is unbelievably expensive. To make it all work without breaking the bank, YouTube has to rely on some seriously clever tricks. Let's look at how they manage the cost.
To understand their biggest cost-saving move, you have to understand this chart. It shows what's known as a long-tail distribution. What it means is that a very small number of videos, maybe 10%, get the huge majority of all the views. Meanwhile, the other 90%, this long tail, are millions and millions of videos that are rarely, if ever, watched. That pattern is everything.
Because YouTube knows this pattern exists, they can make a genius optimization. Storing videos on that super fast global CDN is really expensive, so they only put the most popular videos there. All those millions of other videos in the long tail are kept on cheaper, slower storage. This single strategy saves millions upon millions in costs, and it also lets YouTube host a huge library of niche content that just wouldn't be affordable otherwise.
So when you put it all together, you get the blueprint for how YouTube scales. First, parallelism everywhere. Split big jobs into small ones that run at the same time. Second, use loosely coupled systems, which just means different parts of the machine can work independently without causing traffic jams. And third, optimize everything based on real data, just like we saw with that brilliant CDN strategy.
This incredible architecture of parallel processing, smart transcoding, and data-driven optimizations, it really is what powers not just YouTube, but most of the video internet as we know it today. It's an amazing solution to a massive problem. Which of course leaves us with one last question. What challenges will the video platform of tomorrow need to solve? We're talking real-time interactive streaming, virtual reality, things we probably haven't even dreamed of yet. The engineering journey, it never really ends.